we are going to start something called a derivative. A derivative is a very easy thing to find. I went, before we had break, I think on the Thursday, we talked about like going between dimensions. That's what a derivative is. Okay. So a derivative is easy to work. See, brother? Great. Derivatives are easy to do. There are a couple of things that take place when you have like really goofy looking things. So I'm not worried about having definitions, things like that. Okay, so if I have a constant, which is a number, so if I had like the number 7, and I wanted to take the derivative of number 7, the derivative of 7 is just 0. Or if I had wanted the derivative of 8, the derivative of 8 is 0. So if I have a derivative of a number, it's just 0. Okay? And that's kind of the basic thing. So derivative, a lot of times they have it as d over dx. Sometimes they have it as dy over dx. A derivative, this, I want the derivative of 1. The derivative of 1, what do you think the derivative of 1 would be? 0. Oh, see, you guys learned so much. Okay, I'm done teaching it for a day. All right. All right. So I want to find the derivative of x. Hey, yeah, you're good. Yeah. All right. So now we have to take a look at what am I going to do when I have x? Well, is x the same thing as x to the first power? Feel that's the same thing? Okay. So for a derivative, this is all you do. Bring down the derivative. So 1 comes down front. Okay. And then I have x. And then I'm going to subtract 1 from that. And then what is a letter or a number raised to the 0 power? So x raised to the 0 is 1. So this becomes 1 times 1, which is just 1. Okay? So let's see if we can figure that out here. I want the derivative of x squared. So I'm going to bring the exponent out front. And then I'm going to subtract 1 from that. So 2 minus 1 is? So the derivative of x squared is 2x to the first, or the same thing as saying just 2x. Anybody lost yet? So again, I'm taking an exponent, I'm bringing it out front, I'm lowering the exponent by 1. Does that make sense? Anyone lost? All right. What is the derivative of x to the third? What do you think? What's the derivative of this? 3x squared. Perfect. Yeah. Bring the exponent out front. If there's already a number there, you'd have to multiply it. And then take x to the third and lower it by 1 degree or 1 dimension. So x to the third becomes x to the second. Subtract 1. And then we introduce a variable raised to a variable. Okay, so this is going to be nx raised to the n minus 1. Did that follow the rules that we've been doing? Okay, so now, what really is a derivative? A derivative, as far as a graph would go, if you had a graph and you knew the equation to the graph, the derivative would allow you to find something called the quote-unquote instantaneous slope of the line. Okay, hang on a second. Let's kind of do a little picture over here. Let's say I had a graph that looked like this. Parabola, agree? So let's say this is -1. If I brought -1 straight down to here, I got to this point right here. I could, if I took the derivative, if I took this, which is x squared, and took the derivative of it, I'm going to get 2x. And then if I plugged this 1 right, or this -1 in for x, that would tell me the slope right there at that exact point is -2, meaning that's the pitch of the line going down. Hey, Bob, I guess there was a button that was supposed to have been pushed on the wall in that classroom, so he figured it out.
Very good. Thank you.
Yes. All right. So let's talk about, we have some rules. We have the sum rule and we have the difference rule. Sum means addition. Yes. Difference means subtraction. Okay. So here's, let's say I had some graph that was this. I had y equals x to the third plus 2x squared plus 3x plus 4. And let's say I wanted to find the derivative, which is going to be d over dy or d over dx. So I'm going to get 3x squared plus 4x plus 3, and that's the derivative. Okay, so why does that work? Well, you take it just part by part. Take the derivative of 3x, or x to the third. That 3 comes down front. I lower that by 2, so 3x squared. And then if I take the derivative of this, bring the 2 down front. 2 times 2 is 4. 4x to the first. Take the derivative of this. This is to the first. Bring down the 1. That becomes 3. This becomes x to the 0. We just said x to the 0 is the same thing as 1. And then derivative of the constant, this is 0. So we don't have to worry about it. Okay? So if you're adding things together, you can find the derivative pretty easily just by going part to part to part. Same thing takes place if I were to say I were to subtract if I wanted to find the derivative, d over dx, that's going to give me 12x squared minus 4x plus 5. Okay, and all the signs stay the same. So those are pretty, I think, straightforward. Okay. Then we get to something that starts getting goofier. It starts using language where you read the language and you're like, what? Can I move this up? Okay. Derivative type questions. Write the equation of the line tangent to f at x equals root 16 at x equals 16. Okay, I need to go to Desmos because it's been like 10 days since we've been here. Yeah, we should have a 2-week fall break. I'm in. All right, so if you looked at it and you said, hey, what does y equals or f at x equals the same thing? What does this actually look like? What does the square root of 16 look like? Well, the square root of 16 is 4, right? So that's just a horizontal line. Okay. So square root of 16 is 4. So what do you think the derivative of square root 16 should be? What would the derivative of square root what would the derivative of 16 be? 0. What would the derivative of square root of 16 also have to be? 0. Okay, is the slope of 0 a horizontal line? Take us back to algebra 1. So you might remember this from algebra 1. So if you had a slope of 2 over 3, this is up 2, right 3. If you had a slope of negative 2 over 3, this would be down 2, right 3. And then you had the special cases. There's 2 special cases. You have 0, and this is just a horizontal line. And if it's undefined, it would have to be a vertical line. Okay, so those are like prior knowledge things from algebra 1 that you could kind of think about. Okay. Hey, does it make sense that slope of 2/3 would be up 2 right 3? The slope of negative 2/3 would be down 2 right 3? And then you remember the special cases. Special cases, when we introduced them in algebra 1, we spent like 7 seconds on it and then moved on. You never saw it again. Remember the good old days of algebra 1? All right. So if I wanted to find the derivative of root 16, that has to be 0. So at 16, so on my xy axis, if I go over here to 16 right here, move over 16. Exactly at 16, I'm at 4. If I take the derivative of square root 16, or the derivative of 4, I get 0, which is a flat line. So on this particular thing, write the equation of the tangent line here. Write the equation to the tangent line. Well, the tangent line has to be just 4. This is the horizontal line. Okay, there's not an x value because technically what this really comes out to is y equals 0x plus 4. 0 times x is just 0. Okay. So then let's move down to see what's going to take place here. Okay, find the slope of the tangent line. Okay, so when you start seeing slope, that means a derivative is going to take place. Okay, so if I just convert this to y equals x squared, if I were to go d over dx of x squared, that's going to come out to 2x. Agree? So this is the derivative. That's going to allow us to find the slope. So if I go and I find the slope, I'm going to take 1, I'm going to take 2, and I'm going to take negative 3 and plug them in. So at 1, the slope is 2. At 2, the slope is 4. And at negative 3, the slope is negative 6. These are the slopes. Okay? Again, they're called the instantaneous slope. That means that the slope exists as you go through the problem. So I think I could take this and let me just go on Desmos and graph it. So I'm going to graph y equals x squared, which is a parabola, if you didn't know that. Okay. A little fatter. All right. So what's going on here is this. This is called a meter stick. We're high-tech data right now. So if I were to go, that's not mine. That sounds like my alarm though. All right, if I were to go at 1, does everyone agree that 1 is right here, right there? Does that make sense? So that means that if I were to go exactly to 1, this straight line right here at exactly 1, where it kisses our parabola at 1, that slope right there is going to be, what did I say it was? 2. So this would be up to right 1. Okay, so the slope of this line. If I were to go to the next one where we said at 2, at exactly 2, notice this goes from this to this. Okay, so I went from here, like that, to this. That becomes steeper, right? So the slope is increasing as I continue to start moving along this. It increases to where it starts to approach almost a vertical line, and will never get to a vertical line because a parabola by definition is a function. A vertical line is not a function. Okay, so that's kind of the simple meat and potatoes to that one. Okay. Is this making a little bit of sense? So let's do this. So let's graph y equals 2x. How can I do that? I'm a little bit too, I don't want to do that yet. I was going to show you how I could find the exact equation, but that'll be a lesson later. Okay. Everyone still with me? All right. So let's move down here. So if I want to find the derivative, now we're going to change something. In this book, a miracle kind of took place. You see how that has a little F with a little tick mark above it? That means d over dx. That means you're doing the derivative, first derivative. Derivative. Okay, so if I wanted to find f prime, so we can get rid of d over dx and just do the derivative. So if I want to do the derivative of this, derivative of 7x is what? 7. Derivative of negative 4 is? So 7 minus 0. So the derivative of this is just 7. Let's do the derivative of this. F prime at x. Okay, what's the derivative of x to the third? 3x squared. What's the derivative of negative 2x squared? Negative 4x. And what's the derivative of positive 10x? 10. Friends, we're doing calculus. Woohoo! And just like everything else in math, we got to pervert it. We got to incorporate the F word. We're getting to the fraction. Okay. We have this. So first off, I'm going to rewrite the equation to where I don't have it as a fraction. If I wanted to move this up, I'm going to get x to the negative 5. If I want to move this up, I'm going to get x to the, and I got a 2 there, 2x to the negative 4. Okay? If I move a fraction, if I move it from the bottom to the top, the sign of the exponent changes. If I move it from the top to the bottom, the exponent sign changes. Okay? So now if I wanted to say, I want to find the derivative of this, I'm going to get negative 5x, and I'm going to subtract 1. So negative 5 minus 1 is negative 6. And then if I did the derivative of this, I'll bring this negative 4 down. So I'm going to get negative 2 times negative 4x. I'm going to subtract 1 to the negative 5. Now we can clean it up a little bit. If we can clean it up, remember if I said you have a negative exponent, you can move it back down. So I'm going to get negative 5 over x to the 6th. Negative times negative is positive. I'm going to move this back down over x to the 5th. And we've just taken the derivative. Whew. Questions for me? Good in the hood? What did I do? Oh, I didn't mean to. I didn't mean to. I don't. Just you'd be all right. We'll shampoo the carpets at some point. I know you can fill it up again. It's not? No, there's an ice machine there too. You hit the ice button. Leave that one. I'll. Okay. All right. I would like to have you guys start on this. What did I do? Can I make it big again? Is that good? I'm just do what I can for you. All right, let's go to our worksheet, worksheet 4.3. Oh, hey, is Caillou here?
Yeah.
I've had this for you forever. Clothing. Senior swag. Ready? Good catch. I'm sorry, I've had it for like 3 weeks, and I kept kicking the bag after this class going, oh, doggone it, I forgot to give it to you again. All right, so let's go to our worksheet and take a look at a couple of problems, because something now changed terminology. All right, so it says let f of x equal 2x squared minus 1. So we want to find the derivative first. So what's the derivative of that equation? What's the derivative of this? 4x minus 1, right? Okay. All right. So instantaneous rate of change. Instantaneous rate of change means I want to find the slope. So I'm going to say, what's the instantaneous rate of change at -1? So I'm going to take -1 and I'm going to plug it into my derivative. So I'm going to get 4 times -1 minus 1, which is -4 minus 1, which is -5. So at -1, as far as that graph goes, I would have a slope at exactly at -1 to be -5, or -5 over 1 if you wanted to keep it as a fraction. And then it says, find the point on the graph of f at x. Find the point on the graph. Okay, so this means we're going to change it a smidge. I'm going to take this and I'm going to plug it back in to our original. So I'm going to get 2 times -1 squared minus -1. So that's going to give me 2 plus 1, which is 3, which means the point -1, 3 exists on our original graph. Okay? Does that make sense? I kind of covered a whole lot real quick. The reason I'm jumping on this worksheet is because there was things from the lesson that didn't get covered on the worksheet, so I want to make sure I cover it. So moving down a little bit. So they want to know over what intervals A through D, little a through little d, not capital A, B, C, D, E, A through D. So we're talking about this. So A through D, we want to know where our graph is positive. I didn't want that. Undo that. I'm going to do right here. That right there is the only spot, and right here, those are my only 2 spots between that interval that I would have a positive slope. Okay? Oh, I meant to do that. Okay? So where is it positive? It's positive on the orange. Now, where is it positive, or where is it negative? Where is it negative? It's negative here. And that's the only place it's negative. So we're talking about intervals, but we don't really have numbers to go based off of this. But we're talking about that. And it says, at what points A through E, now we're doing the capital letters, is the rate of change equal to 0? Okay, where is it equal to 0? It's equal to 0 exactly there and exactly there. Okay, so, oh, and it's right there. So where things are 0 is when the graph goes from up to down or down to up. So up to down, that happened there. Down to up happened right there. And then up to down, it happened right there. Okay, meaning if you were to take those numerical x values, which we don't have on this graph, if we took the derivative and we plug those values in exactly at where A and C and E are taking place, that would give us an answer of 0. That means the slope is 0. That means it's a horizontal line. And then where does it change from positive to negative? So this is a positive slope. This is a negative slope. This is a positive slope. This is a negative slope over here. So going up to down. Okay, so where does it change from positive to negative? That takes place at A, and positive to negative, and at E. A and E is where it changes from positive to negative. When it changed from positive to negative, that means that exactly at that spot where it changes from being a positive slope to a negative slope, that means that the instantaneous slope at exactly that point becomes 0. That means a vertical line or a horizontal line took place. So this is, in a nutshell, what that just meant. Okay, the yellow dots are local maxes, and the green dots are local mins. Okay, which that means is the slope going up to here, these are all positive slopes, gets to right here, it's 0, then it's negative. As I go down here, this is all negative, then it's 0 here, then it's positive, 0 here, negative, 0 here, positive. So that's what the slopes at those things are. So where it's positive is where the graph is said to be increasing. And where it's negative is where the graph is decreasing. Oh boy. All right. So that's enough for me. Will you try the best you can to get through worksheet 4.3? If you get to one that you're not sure about, if there's time in class, ask me. If there's not time in class, then ask me tomorrow. Deal? This Friday, we will be doing something called fair division, which is basically a state division. I heard you couldn't make that work.
Yeah, it's worked out. Wow.
Okay. Is that one? Is not that one? So that's what you guys figured out.